All right. Thank you everyone for joining our webinar on the latest happenings around medium voltage switchgear today. I'm Maliha Tariq. I'm the content marketing manager at Power Technology Research. With me today, I have um, two market research analysts who specialize in the switchgear content, Saifa Khalid and Mohammed Usman. Saifa is also the Power Grid team lead, and Mohammed Usman is a very experienced analyst within the Power Grid team at Power Technology Research. Can we move on to the next slide? Let's begin with a brief introduction for Power Technology Research. We are a market research firm specializing in power grid and new energy equipment research. We help businesses and clients in their strategic decision making with our bespoke content reports, and these reports include both quantitative and qualitative analyses. Moving on. Within the power grid sector, we cover everything from switchgear to facts to power correction systems and others. Coming to our webinar topic today, we know that since medium voltage switchgear is set to expand due to the renewables share of electricity generation being projected to reach around 40% by 2030, it's a compelling case for encouraging investment in SF6 alternatives. Um, this webinar will present an overview of the climate change policies and current legislation on the usage of SF6 alternatives in medium voltage switchgear. Additionally, the impact on the global MV switchgear market due to European Union's recent proposal on the ban of SF6 on all electrical equipment after 2030 will also be analyzed. So I'm just gonna move to our analysts to start the presentation and take it over. Saifa, over to you.
Thank you so much, Maliha, for inviting me to this webinar and for introduction. I would like to, I am a market analyst at PTR. Along with me is my colleague, Mohammed Usman, who is going to discuss with the topic with me. Before discussing the content of the webinar, will electrical industry succeed in phasing out SF6 from switchgear industry? I would like to walk you guys through the agenda of the presentation. So first of all, we'll discuss MV Switchgear service overview, what we have at PTR. Moving on, we'll discuss the definitions. It is important to discuss the difference between AIS and GIS. Moving on, we'll discuss about the usage of SF6 in electrical industry and others. Moving forward, I'll give you a brief overview about the MV switchgear market landscape, what happened in MV switchgear market in 2021. Then evolving targets of clean energy would be discussed, and then legislative processes around SF6 would be discussed, and towards the end, we'll discuss about SF6 alternatives and conclusion. So to start with a quick overview about MV switchgear service. At PTR, we cover MV switchgear service for overall. Like it's a complete information package that includes traditional market sizing. Where we are not only looking at the annual sales of MV switchgear, but we also cover the install base. In terms of time series element, we are covering the market from historical perspective, 2018 to 2026, whereas from the future perspective, we are covering the market from 22 till 2026. We are covering the market from different verticals like utility, generation, that includes wind, solar, and conventional. And then industries further segmented into different energy intensive industries, automotive, ONG, and others. From the equipment type, we are depending on the usage in distribution network. We are covering the market from primary switchgear, secondary systems, and outdoors. In terms of voltage levels, we are covering 4 voltage buckets from 1 to 42 kV. The purpose of mentioning our service over here is that the data you will find regarding the market sizing is extracted from our own information we have on MV Switchgear. Moving on, like before we delve into the topic of SF6 and its usage in energy industry, its impact on the environment, and its alternatives available in the market, it is important to discuss the basic definition of AIS and GIS. What's the main difference between the two technologies, and how these technologies differ from each other. As the name implies, the major difference between two is the medium of insulation used for bus bar insulation. GIS, in case of GIS, SF6 is the major insulation media for busbar. However, as the name implies, AIS is a major insulation media for busbar in AIS category. The major reason for preferring GIS over AIS is its small size and low maintenance requirements. As the equipment is fully sealed in case of GIS, therefore GIS is preferred in harsh environmental conditions. Moving on, this slide is just give you an overview about the equipment cover under MV Switchgear coverage. This is a product portfolio of different companies. It's the purpose of mentioning over here is to give you guys an overview about medium voltage switchgear equipment available in the market. All tier one players, Eaton, Siemens, ABB, or Schneider covers the market from different perspective depending on the distribution level. Like we have primary switchgear that is employed in HV to MV primary distribution, and then we have secondary switchgear that is employed in secondary distribution. Depending on the insulation, it is categorized into AIS and GIS. First four categories, AIS primary, GIS primary, AI secondary, and GIS secondary, would be utilized usually indoor. However, overhead equipment includes outdoor circuit breakers and reclosers. The prime focus of our discussion during the webinar would be indoor equipment. In that, particularly, we would be focusing on GIS primary and GIS secondary, as these employs major SF6 gas in it. So, before discussing about SF6 impact on the environment, I would like to give you an overview about SF6 and its usage in energy industry. SF6 is basically a man-made gas, which is extremely potent and have high greenhouse gas potential. It is approximately 23,500 times more greenhouse than carbon dioxide, and it can stay longer into the environment up to 3,200 years, which is extremely dangerous for the environmental concerns. Uh, in terms of European Green Deal, there is a push to reduce greenhouse gas emissions by 55% by 2030. And to achieve this target, EU adopted Fit for 55 package back in July 2021, in which it introduced a series of proposals covering different areas like climate, land use, energy, transport, taxation, to bring them in line with the targets agreed in European climate policy. Despite being so harmful gas, it is extensively used in electrical industry, particularly in HV and MV switchgear. The main reason for employing SF6 in switchgear is its excellent insulation properties, arc quenching mechanism, and important and crucial point to mention over here is the reduction in size of the electrical equipment is also very important by using SF6 over here. So it has been used, SF6 has been in use in electrical industry for more than 6 decades now. And it is important to mention over here, like 75% of the total greenhouse gas emission in EU comes from the energy sector, whereas 85% of all SF6 that is produced globally is used in electrical power industry. And out of that, 90% of the electrical equipment that utilizes the SF6 is basically switchgear. That includes both HV and MV switchgear. Emission from electrical industry equipment are primarily due to switchgear leakages during operation, and this applies to both HV and MV switchgear. On we'll discuss the usage of SF6 in different industries other than the electrical industries. We have mentioned previously that SF6 is being used extensively in gas insulated switchgear. It is also used in other electrical equipment like gas insulated lines, circuit breakers, and transformers. Apart from that, it is used in industries like magnesium, production of magnesium and in recycling operations of magnesium to prevent oxidation and burning due to its excellent properties. Another large use of SF6 is the manufacture of semiconductors, where it is used in plasma etching process. SF6 is also used in particle accelerators and military aircraft radars. All these applications account for SF6 emissions in the environment and adds to greenhouse gas emissions as well. So it's important to look at SF6 alternatives in the market. To reduce the SF6 impact on the environment, it has been the usage has been discontinued or reduced in many industries. For instance, soundproof windows, shoe soles, and tennis balls. All these industries utilize SF6 in one way or the other in the past, but now, owing to its harmful impacts on the environment, it has been discontinued from these industries. This is just a brief overview about SF6 and its usage in different industries apart from electrical industry. However, our prime focus today would be electrical industry and particularly gas insulated switchgear. This section would cover the overview of the market sizing. What is the market landscape in the last year, especially 2021, and what it has in terms of market values, in terms of electrical insulation equipment used. So moving on, uh, this uh, this is a brief overview about MV switchgear landscape in the past, especially in the year 2021. According to PTR analysis, in 2021, annual market of MV switchgear unit is about approximately stands around 20 billion USD, and this includes both primary and secondary switchgear. And in terms of insulation technology, it includes both AIS switchgear and GIS switchgear. If we talk about the amount of GIS installed switchgear units, it stands around 52%. Like 52% of the annual units that were sold back in 2021 were GIS based switchgear. GIS recently got traction in the last few years due to increased penetration of renewables. From the application point of view, if we discuss the usage of MV switchgear, 61% of MV switchgear demand is being generated by utility sector, whereas renewable, the demand is small right now, like it stands at 18%, but with the increasing penetration of renewables into the energy mix, the demand is continuously going to increase and it would impact the major market of gas insulated switchgear. As our research indicates that currently in 2021, 70% of the installed switchgear in renewable sector, particularly wind and solar, were GIS-based switchgear compared to other industry where the relative ratio is quite small in other industries. So moving on, we will discuss about the clean targets of clean energy and how these targets are going to impact SF6 market overall, how these are going to impact the environment. So let's discuss the targets one by one. Global energy policy, especially after Paris Agreement, we have seen that it is driven by climate change and environmental concerns. The Paris Agreement is a landmark in the global effort to combat the climate change, and over 190 countries signed it back then. The agreement aims to reduce the greenhouse gas to limit the temperature rise to 1.5 degree. And we have seen that the countries around the world are increasing the penetration of renewables into their energy mix just to achieve their carbon neutrality targets, which are set by themselves. They have set the renewable as well as carbon emission targets for themselves. For instance, if we talk about France aims to reduce its carbon emissions by 40% by 2030. Similarly, Italy plans to reduce the emissions by 60%. And if we talk about Germany, Germany plans to become carbon neutral by 2045. To achieve this carbon neutrality, they are highly investing in renewable energy. This could be evident easily from 2021 figures. Like due to global uncertainties, every industry is impacted. However, in case of renewables, by the end of 2021, the share increased to 9.1% by the cumulative addition of around 257 gigawatts and contributed to 81% of the global power share. Renewable share of electricity generation is projected to increase by 40% by 2030 to achieve the zero future. It could be easily seen from the graph over here. Like in the last 5 years, the renewable capacity addition stands around 1200 gigawatt approximately, and in the next 5 years, the capacity additions were projected to increase and reach to 1500 gigawatts. And if we particularly talk about utility scale and wind solar, utility scale solar is expected to increase by approximately 60% in the next 5 years. Similarly, if we talk about wind, there is also a boom in the wind industry. Onshore wind is relatively a slow growing market as it is already matured enough, and it's expected to increase by 5%, 15% in the next 5 years, from 328 gigawatt at present to 373 gigawatt. Whereas in case of offshore, if we see, the offshore capacity addition is expected to double in the next 5 years. Like currently, in the last 5 years, only 31 gigawatt of offshore wind capacity is added. However, in the next 5 years, we could see that 72 gigawatt is in pipeline, which needs to be added in next 5 years till 2026. If we talk about the renewable sector and usage of SF6 in the renewable, we have discussed previously that renewable is the biggest demand generator for GIS-based switchgear, and it is easily understood as the major amount of secondary switchgear is employed in wind energy, and that employs GIS-based switchgear. The major reasons for employing GIS in wind are its compact nature and resistance to harsh environmental conditions. The switchgear needs to be installed at the base of the wind turbine, and there is quite limited space. Therefore, it must be compact enough so that it could easily fit into the base of the wind turbine. And wind offshore farms are usually installed in the seas, where they experience a lot of temperature variance, humidity, salinity problems, etc. And GIS, because of its sealed nature, it is resistant to all these harsh environmental conditions, and it could bear them easily, compared to AIS-based switchgear, which is prone to be damaged by all these environmental impacts. If we talk particularly from SF6 emissions in renewable sector, transition transition towards less carbon intensive energy is basically the central goal of EU's plans, and this translates to the need of more and more renewable energy. But we have discussed that the major switchgear that is employed in the renewable is contains the powerful greenhouse gas, that is SF6. The sales of SF6 based switchgear is expected to increase in the renewable sector tremendously. If we talk about from the prettier perspective, the annual market of GIS-based MV switchgear in renewables, particularly wind and solar, is expected to grow with a CAGR of 5% on average globally from 21 to 27. Consequently, the increase in the demand for GIS, the share of SF6 emissions from GIS-based MV switchgear in the renewable sector will also increase. And opting for MV SF6-based GIS, resulting approximately to 674.3 million carbon equivalent emissions, which is extremely high value and could impact the environment severely if not controlled. Another solution we have available is we shift our focus towards SF6 free solution, which we will discuss in detail in the next sections moving on. So now Mohammed Usman will discuss the legislative processes around SF6. Usman, over to you.
Thank you, Saifa, for this excellent presentation. I'm going to cover the legislative processes over the years by which European Union have progressed towards phasing out F-gas in general and SF6 in particular from different markets. However, the focus will be on the electrical industry by and large. This slide shows some of the regulations, directives, and reports that we will be discussing today, arranged by their year of proposal, adoption, or publication. Next slide, please. This is the European Directive on MAX. MAX stands for Mobile Air Conditioning System. To reduce emissions of F-gases, European Directive was introduced as a gradual ban on these gases in passenger cars in 2008. Starting from 2017, F-gas with a global warming potential higher than 150 was no longer allowed to be used in the MAX systems. by reducing these emissions, the directive contributed to the European Union's strategy for climate action. Although not directly related to the electrical industry, this shows that as F-gas regulations grow more stringent, they will increasingly affect SF6 regardless of the application. Next slide, please. Before discussing the core aim of the F-gas regulations of 2014, a small background on why these regulations were needed. It was found that during the 2014, F-gas emissions amounted to 2.5% of European Union's total greenhouse gas emissions, which was itself an increase of 100% from that in 1990. In contrast, other greenhouse gas emissions fell during the same period. It was found that this is due to the F gases in the past typically replaced ozone depleting substances in the areas where the latter became prohibited to use to protect the ozone layer as required under the 1987 Montreal Protocol. So in response to this, a major step towards reducing the SF6 was taken in 2014 when amendments to the original 2006 regulations were proposed and later adopted. Through these amendments, the European Union had set the goal of reducing its F-gas emissions by 2/3 by 2030. Although much of this was to come from using less of the gases covered by the Montreal Protocol, SF6 was an integral part of the mix. Important articles of these regulations are shown here. These were related to specific measures that were to be implemented to achieve the core aim of these regulations. In addition to the technical data and specifications mentioned in the draft, these articles detail the processes of phasing down of HFCs in various applications, limiting the total amount of HFCs that could be sold in the EU, banning the use of some F-gases in many new types of equipment, and preventing SF6 emissions through monitoring, servicing, and end-of-life gas recovery in electrical switchgear. In electrical switchgear, SF6 recovery is especially important because the most climate-damaging driver of SF6 involves the potential equipment end-of-life emissions. This process for a unit of medium voltage switchgear encompasses the final journey of SF6 from its extraction from the equipment to transportation to ultimately recycling or destruction. Lastly, to achieve these aims, some articles focus on providing essential training to personnel handling the SF6 gases, and some were tasked with the companies clearly labeling their equipment that contain hydrofluorocarbons. Next slide, please. In the F-gas regulation of 2014, it was tasked to form a commission to assess whether cost-effective, technically feasible, energy-efficient, and reliable alternatives existed to SF6 in new electrical equipment. The idea was to understand if the replacement of fluorinated greenhouse gases was possible or not in upcoming years. In 2020, a report was published that responded to this requirement and focused on new medium voltage primary and secondary switchgear, as well as allied electrical equipment. Switchgear with higher voltages was considered as well. The findings in this report are serving as a technical input to the latest 2022 review. The conclusion from this report was that for new medium voltage switchgear and that was used in secondary distribution, SF6 was currently the dominant technology for both installation and breaking and switching. However, for certain applications for up to 24 kilovolt, commercial alternatives for installation had started to become available. Moreover, the technical characteristics of these equipment, such as the physical dimensions, technical life, and reliability, were apparently identical to equivalent solutions of the same manufacturers that use SF6. Commission also estimated that different types of switchgear in the product range could become available from 2022 to 2025, of course, depending on how advanced the development and testing was going to be for each type. However, in some special cases, it was found that it will be difficult to replace SF6, for example, due to special space requirements or environmental conditions. Another conclusion was that the vacuum circuit breakers were a technically feasible alternative for switching applications, but the main obstacles to a wider uptake in secondary distribution were the need for maintenance and complex and costly changes that would be required to mitigate the risk of compromising the selectivity of the protection system. Lastly, it was also suggested by the Commission that for medium voltage secondary switchgear, a complete replacement be preferred over a partial retrofit. For the new medium voltage primary distribution switchgear, Commission found that the SF6 free alternatives have always been available and more solutions were being developed. Characteristics like physical dimensions of the equipment, their technical life and reliability were apparently identical to the equivalent solution of the same manufacturers that use SF6. Commission was of the view that after full market deployment, only marginal additional cost will be expected because the designs of alternatives were very similar to the products that use the SF6. Full commercialization of the alternative solution was expected by 2023. Lastly, braking was not an issue in primary distribution as vacuum circuit breakers were already common by 2020. Commission was of the view that for medium voltage instrument transformers and capacitors, the potential alternatives at that time did not deliver satisfactory results, and they were of the view that instead of developing new products, following the best practices that were outlined in the regulations was a good idea. However, for the medium voltage bushing, for medium voltage gas insulated lines and gas insulated bus bars and bus ducts, penetration of alternatives could become relatively high by 2025 for certain voltage ranges. Lastly, in the high voltage domain, Commission expected that for voltages up to 145 kV, commercialization of SF6-free equipment portfolio was expected by 2025. Moreover, solutions for voltages even higher, that is, for example, up to 245 kV, might also be introduced by 2025 with commercialization later than that. As far as price was concerned, this report was of the view that in 2020 it was observed that in general, where the SF6 free alternatives were mostly costly than the switchgear containing SF6, and policy intervention was likely required to be needed to trigger a transition. Next slide, please. In the previous 2014 regulation, it was required that a study be commissioned to assess that how much successful these regulations were. So they were assessed against 5 key evaluation criteria, and the data selected was between 2015 and 2020. The metrics that were selected were effectiveness, efficiency, relevance, coherence, and EU added value. For effectiveness, the study was going to be about how successful EU action has been in achieving or progressing towards the original objectives of the intervention. For efficiency, they studied how proportionate the benefits of the regulation have been to the cost. For relevance, they studied whether the original objectives of intervention are still representative of the current needs of society. And for coherence, it was tasked to identify any internal gaps, overlaps, inconsistencies within the F-gas policy framework, and also compare with the other international policies to see if there are any deficiencies. Lastly, the report was to understand whether the implementation of the regulation at European Union level has exceeded the value which could have been achieved at the lower member state level. So findings of this report was published just a few months ago in 2022 March. The report concluded that the F-gas regulation has led to a reverse and a year-on-year decrease of F-gas emissions starting in 2015. With regards to the effectiveness metric, Saifa, just go to the previous slide. With regards to the effectiveness metric, the report concluded that the F-gas regulations have led to a reverse, and the EU market supply of HFCs has declined by 37% in metric tons and 47% in terms of CO2 equivalent from 2015 until 2019. There has also been a clear shift to the use of alternatives with lower global warming potential. These alternatives included CO2, ammonia, hydrocarbons, and even water. In many types of equipment that use F-gases traditionally. However, the emission saving was found to be not fully achieved, and it was suggested that there is an unused potential and more stringent regulations be required to save even more emissions. Moreover, with regards to the SF6-free switchgear, reports suggested that regulation should promote the deployment of these alternatives even more aggressively. With regards to the efficiency metric, overall findings of the report were that the regulation has resulted in significant emission savings at very low abatement costs linked to the technological change. With regards to the relevance metric, findings suggested that while the F-gas regulation was adopted ahead of the Kigali Amendment to the Montreal Protocol, and while it was instrumental in achieving the global agreement, the regulations needed to be more compliant with the obligations, with all the obligations after 2014. Lastly, with the coherence metric, the overall findings of the report was that the regulation interacted with several regulatory instruments, both in form of other EU policy and also international agreements. In general, the regulation was found to show a good level of consistency and coherence with other interventions that have similar objectives from other regions and other countries. Next slide, please. So on 5th of April 2022, this year, the European Commission released a legislative proposal to update their 2014 F-gas regulations in order to more tightly control the fluorinated greenhouse gases, including the SF6 emissions. Reasons for the proposal was, as I mentioned, I'm just going to summarize here, was the EU Green Deal, which was first presented in 2019, and it prompted the European Union to enhance their climate change targets so as to ensure a new era for the continent to transform it into a society with modern and resource-efficient and competitive economy. This also meant a basis of an ambitious plan by the Commission to decrease emissions by 55% till 2030 as compared to 1990. Previously, this was 40%, and make Europe the first climate neutral continent by 2050, as mentioned earlier by Saifa. This was considered as Fit for 55 package and was adopted in 2021. Furthermore, it aimed to protect the health and well-being of citizens from environmental-related risks and impacts. The second reason for this proposal was the European Climate Law, which was adopted in 2021 to establish a binding net greenhouse gas reduction target and was based on the Green Deal. The third reason to for this proposal was the amendment to the Montreal Protocol, as I've mentioned earlier, that European Union F-gas policy amendments should be seen in the context of the 2015 IPCC special report, which suggested that in order to limit global warming at 1.5 degrees centigrade, the required F-gas emissions must decrease drastically by up to 90% by 2050 compared to 2015. So implementation of the Kigali Amendment to Montreal Protocol started in 2019, and with an aim to reduce this HFC production and consumption by more than 80%. And this proposal was lacking this, and this was one of the reasons for this proposal in 2022. Fourth reason was the evaluation of 2014 F-gas regulation. As discussed before, the Commission concluded in 2022 that the F-gas regulation has led to a reverse and year-on-year decrease of F-gas emissions starting in 2015. They proved to be very effective and influential, but they were found lacking in some aspects, and there was a room for even more stringent requirements that the 2014 regulations did not enforce enough. Lastly, the European Union has gained enough experience after 2014 to understand that the implementation of regulation as well as the feedback received from stakeholders confirm the need to address a number of challenges to a quota system that was introduced in the 2014 regulation. All of these five led to the general objectives for the F-gas policy review 2022. These general objectives include the discouraging the use of F-gases with high global warming potential and encouraging the use of alternate substances, preventing leakages from equipment, especially from switchgear, and ensuring that they have proper end-of-life treatment, enhancing sustainable growth, stimulate innovation, and develop green technologies by improving market opportunities for alternative technologies in the electric switchgear. Next slide, please. So based on these objectives, some important milestones that the F-gas regulation review of 2022 has is that firstly in 2022, if it's approved this year, it's going to repeal the 2014 regulation, and it's also going to increase the F-gas emissions reductions by so much that by 2030, the 55% of the emissions should have reduced, which was again, as I've mentioned earlier, 40%. And by 2050, EU should be carbon neutral, and a total of 490 million tons CO2 equivalent greenhouse gases should have been removed. A point I would like to focus on that during the second milestone, 2030, some electrical switchgear will be phased out and it will be prohibited to use SF6 in either of these. I'm just going to give you a small summary of what to expect, what is suggested in this proposal. So for medium voltage secondary and primary switchgear that has voltage less than 24 kV and uses SF6 for either insulation or switching, the prohibition date is January 1st, 2026. For medium voltage switchgear with higher voltages greater than 24 kV but less than 42 kV, the date for cutoff is January 1st, 2030. For high voltage switchgear that has voltages higher than 52 kV but less than 145 kV, prohibition date has been suggested as 2028, January 2028. And lastly, for equipment with voltage exceeding 145, prohibition date has been suggested as January 2031. So this essentially means that SF6 is proposed to be phased out in all new electrical equipment by 2031. So what will be the next steps after that? EU will debate on these proposals and whether these regulations are passed or not. Previous F-gas regulations will remain. So phasing out of SF6 should be considered imminent anyway. And achieving those objectives will have a chance for us to keep the global average temperature less than 1.5 degrees centigrade and implement the all the Montreal Protocol as well. So that's it from my side. Back to you, Saifa.
Thank you so much, Usman, for giving an overview about the legislative processes about electrical industry around SF6. So moving on, we will discuss about SF6 alternatives that is available in the market. Where we'll discuss where does the technology stand today, how this technology is going to evolve, what's the comparison between the technology of SF6 based switchgear and SF6 free switchgear. As we all know that electrical industry is clearly focusing on reduction of carbon footprint with greater push towards the renewable energy sources as a plan of action. However, fossil fuel based generation is not only the aspect of the electrical industry with negative impact on renewable. We have discussed throughout the presentation that SF6 in electrical switchgear has playing an important role in adding to the greenhouse gas emissions, and it is highly debatable point for the last few years as well. As the evolution of any technology, alternatives to XF6 have been introduced in the market, and it creates an era of green switchgear. To gauge the industry's reaction and acceptance of SF6 alternatives, it is quite important and noteworthy to mention that the detailed comparison is made between SF6 based switchgear and SF6 free switchgear that is available in the market. If we talk about the technical features of both technologies, in terms of technicalities, SF6 based and SF6 free switchgear are more or less in par with each other. For example, like if we talk about insulation capability and arc quenching capability of both technologies, they should be at the same level as both follow IEC insulation standard. It is important that there should be distinction between insulation capability and arc quenching capability. Insulation can be solved easily by using SF6 alternate gases that are available or solid dielectric material, while none of the alternate gases really offer suitable arc extinguishing properties. As we could see that those alternate gases do not make the arc extinguishing phenomena quite worse, but in some cases it may help a bit to consolidate the insulation distance of the switching device, but none extinguish the arc like SF6 does. So if we moving on, like if we discuss the breaking capacities of both SF6 based switchgear, SF6 free primary and secondary GIS target equal breaking capacities as SF6 based switchgear, since performance requirements are mandated by the network structure. However, if we look at the voltage and current ratings of the products offered for SF6 alternatives, they are currently available in the market up to 24 kV, but some solutions are being available up to 45 kV as well. But OEMs are continuously in efforts to make it more reliable and equivalent to the applications. And they are increasing the voltage ratings, they are increasing the current rating to make it in line with the application requirement. Moving on, if we discuss the total cost of ownership of SF6 free switchgear and SF6 base switchgear, it is very important that the initial cost of purchase, if we consider initial cost, it is 15 to 25% higher than SF6 base switchgear, which is extremely high in terms of amount. And in some cases, it could even increase to 30%. However, as the demand, but it can be seen from the market perspective that as the demand increases, there would be an increase in the demand increase would cause the price to go down, and the overall price would initial cost of purchase would become in the limits. If we consider the maintenance cost, both SF6 based and SF6 free switchgear have this more or less similar maintenance cost. The maintenance is irrespective of the technology used, so the cost is similar in this case. However, if we discuss end life cost, it is important that SF6 based switchgear and is more have more end life cost compared to SF6 free switchgear, as we can see that SF6 free switchgear has end life cost of approximately 25% less compared to SF6 base switchgear. So in total, the cost of ownership of SF6 free GIS is considerably less compared to SF6 base switchgear. This is mostly because GIS requires special training for handling purposes while filling the switchgear with SF6, as well as recycling of the switchgear and life and all other phenomena add up to the total cost of ownership, resulting in lesser than SF6 base switchgear. Now, I would like to discuss why, if we consider the total cost of ownership less, then why the industry is not moving towards SF6 free alternatives. There are few bottlenecks that are present in the market, and first and foremost is reluctance towards SF6 free switchgear. As we know that electrical industry is quite conservative regarding enhancing technologies such as switchgear. They are a developed system that is quite old, and the equipment used in the system is already embedded, and it fits exactly in the centralized T&D network. So T&D operators are not very willing to move towards a new technology that would add to their challenges, that needs the upgradation of their network. If we talk from the maintenance perspective, the existing maintaining an existing network is easy compared to introducing a new technology and moving towards its maintenance. So overall, the utilities are reluctant in adopting new technology, and same phenomena could be seen in SF6 free technologies over here. Moreover, moving on, there is a quite question mark on the reliability of SF6 free switchgear available in the market. It's a general perspective that SF6 base switchgear is more reliable compared to SF6 free switchgear. However, it's not the case, and it can be concluded from various studies that technology adoption is quite slow in a utility sector, and it has a snowball effect. Therefore, as more and more utilities going to adopt SF6 free switchgear, the barrier of lack of reliability perception will start to disappear, and SF6 alternatives would be more and more easily able to integrate into the existing networks. If we talk about the existing GIS technology, has proved its reliability and safety for decades now. It has been in use for many decades, and it provides technical and economic feasible solution. Therefore, there is no driving force towards SF6 free GIS. The existing utilities or system operators are quite easily adjustable to GIS, and they don't want to move towards any new technology that is SF6 free GIS free switchgear. Therefore, it's a general idea, and PTR believes that only regulations will be able to compel the market conditions to change. And we have seen in the previous discussion that there were a series of regulations and legislative processes going around towards making SF6 free switchgear more common than SF6 based switchgear due to its environmental impacts. If we talk about SF6 alternatives available in the market, there are many alternative solutions available that uses dry air, air plus solid dielectric as an insulation between them instead of SF6. And it is important to mention that viable MV SF6 free solutions have been available in the market for approximately 60 plus years now. And if we consider the total cost of ownership of SF6 free switchgear, it is considerably less compared to SF6 based switchgear. And a complete portfolio of SF6 alternative exists up to 24 kV as discussed before. The footprint, additionally, there is an effort to reduce the size of SF6 free switchgear and reach to the same level of compactness as SF6 based switchgear. The industry should consider towards switching towards green switchgear to combat the climate change. Switchgear manufacturers rapidly developed SF6 alternatives, as we could see that all the tier 1 manufacturers, ABB, Eaton, G&W Electric, and all, and many others, are effectively manufacturing SF6 free switchgear. And after F-gas regulation, the movement in developing SF6 free switchgear is more and more, and OEMs are rapidly developing SF6 alternative solutions. Bottleneck in the replacement of SF6 based switchgear by SF6 free switchgear is not the lack of viable solutions available in the market. We could see that all major tier 1 or global players are offering SF6 alternative solutions. But the issue lies at the end user. And OEMs and switchgear manufacturers have to do a lot of effort to convince end customers to shift towards SF6 alternatives from SF6 based switchgear, so that countries on a global level could achieve the carbon neutrality targets set by themselves and add to the greenhouse gas emissions reductions as well. This is all about the SF6 alternative. Let's jump to the conclusion. What is the impact on SF6 on the overall environment? How utilities are adding to the reduction of SF6 from their system, and how renewable is going to impact the system? We have discussed before that efforts are being made towards the to combat the climate change by reducing greenhouse gas emissions on a global level, and renewable is the major instigating factor behind that. Apart from that, EVs are also being added into the grid to shift the conventional transport system from fuels that adds to the greenhouse gas towards EV. All these renewables and EV uptake would add to the demand of switchgear. And if we talk particularly, it will add to the demand of GIS-based switchgear. As we have discussed previously, the major amount of switchgear that is employed in the renewable sector is basically SF6-based switchgear. We could see that SF6 free HV switchgears are quite few that are available in the market, but there is a product range of MV switchgear, so it's a better opportunity to shift MV switchgear towards SF6 free alternatives to reduce SF6 emissions. If we talk about, if we discuss about the impact of renewable, overall, the eyes of the globe is on the EU for 2022 revision of F-gas regulation. As Usman discussed, that their proposal has been given that it suggests to ban the usage of SF6 in electrical equipment by 2031. And it would be, if it is realized, it would be a deciding factor that could enforce SF6 alternatives. If we talk from the past, a step has already been taken in this direction with the Journal Administrative Regulation for the procurement of climate-friendly services and prohibiting the procurement of MV SF6-based switchgear for federal agencies in Germany from January 2021. According to PTR, electrical industry will become #1 emitter of SF6 sometime between 2026 to 2030. And renewables are the key driver for switchgear additions, even though currently they have very small installed base. But with the increasing growth in the renewable, there would be in proportion growth of the MV switchgear demand, and you could say there would be a growth of SF6 base switchgear. Given the main purpose of renewables, adding renewables into the energy mix is to reduce greenhouse gas emissions from the environment. And what type of equipment should be used will incentivize renewables, will be the first industry to shift towards SF6 alternatives. As a renewable is a comparatively new era, a new technology, you could say new sector, and it is more open to new technologies compared to other applications, particularly the utility sector. We could conclude that SF6 alternatives are slowly making their way into the electrical industry owing to the environment-friendly nature. Sooner or later, SF6 based switchgear are going to be replaced by SF6 free switchgear to visualize the carbon-free future. And PTR believes that legislation processes that are going on will help to phase out SF6 from electrical industry. However, we believe that this process is going to happen step by step, starting with Europe, and this effect will trickle down into other regions as well. Europe has relatively high demand of SF6 alternatives currently compared to the other regions, and it's mainly because of ongoing F-gas regulations, reviews on the F-gas regulation, which will limit the use of SF6 based switchgear in Europe in the coming years as well. We have seen that some customer demand is also being generated for SF6 free in the Northern Europe, particularly if we talk about the countries Norway, Sweden, and Finland. They are generating the demand for SF6 free switchgear, but it is mostly pertaining to the transmission sector. Nevertheless, we could believe that this will present a positive outlook for the future of SF6 free GIS based switchgear market moving forward. Thank you so much. That's all about the webinar. Question answer.
All right. Thank you very much, guys. They were amazing presentations. I already see so many questions in the chat. Let's go with the first one. Are there any USA-based F-gases emissions reductions initiatives? Saifa, do you want to take that?
Let me take
All
this.
right. All right.
So at federal level, EPA has partnered with electric power industry since 1999, and they have they have a very big, huge initiative that has been very successful in reducing the SF6 emissions. And at the state level, California CARB, the Air Board, has decided, the California Air Resources Board, they have stipulated that by 2033, they want utilities to stop buying any SF6 insulated products. So the work is still going on there, but they still have a long way to go. But pound for pound, there are no such regulations, but EPA has done a lot of work, and it is expected that they are going to come up with even more strict regulations in this decade.
All right, all right. Moving on. The second question is, in SF6 free MV switchgear, which medium will be used for insulation to reduce the footprint of panel?
Okay. As I have mentioned during the webinar as well, like there were different media of electric insulation medium that are employed as an alternate to SF6. For instance, for our quenching principle, we have vacuum. For electric insulation medium, we have dryer. We have combination of natural gases like O2 and N2. Apart from that, we also have like combination of F gases and other natural gases like 5 to 15% F gas and then a 5% O2 and 2 gas. So these are some of the insulation medium that are employed for SF6 alternative solutions available in the market.
All right.
I hope.
Okay. The next question is, are there similar regulations in North America as well?
As I mentioned that EPA has been partnering with electric utilities since 1999, and basically they have spearheaded the effort to curb SF6 emissions. They have a very good program where they help utilities, industries, companies monitor any SF6 leakage and provide them with the best practices regarding the end of life uh, recycling or destruction of SF6. So as I mentioned earlier, EPA has a partnership, and rest is up to the states to ensure if they want to follow the EPA guidelines, letter and spirit, or they want to have their own regulations.
Okay, moving on to the next question. There is no IEC so far for governing body for SF6 free equipment. Can you please share some standard and conformity assessment guideline for SF6 free system?
Like we don't have any top of the head, but we can look into it and get back to you via email.
All right, okay. Next question is, when are the regulations expected to be debated?
Before the end of this year, because the proposals have already been forwarded, and the legislators have also been briefed. So I think we can expect any result by this year end.
All right, the next question is, what is the future of solid dielectric switchgear?
Okay, solid dielectric is currently available in the market as an insulation media and as an alternative to SF6. And it is considered that it is a solution to all the problem, because even if we consider AIS instead of SF6 based GIS, although SF6 is not used as a gas in the compartment for insulation of the bus bar, but it is still being used in, you could say, in disconnecting switches or in circuit breakers or for arc extinguishing media in one way or the other within the equipment. So solid dielectric switchgear, which is completely free from the use of SF6, can be answered to addressing environmental issues. But the issue over here is that the current and voltage limitations along with the configuration considerations make it less desirable overall. For secondary switchgear, there is no current limitation, and there one can see the main application for this type of switchgear. The distribution voltage levels, it is viable option, but it is less popular as compared to its counterpart, that is gas-based SF6 alternatives, due
All
to
right,
overall properties.
okay. Last question is, can you please brief on stand of EUSSCA?
So I'll take that. I think I will be better able to answer if I get this information and get back to Mr.
Javed Akhtar.
Javed Akhtar Saab later through email. But I'm sure that since they're launching of the sustainability project in 2018, they do have some best practices regarding that. So I'll have to look into it, and I can share my brief through the email after the.
All right, then that's it for the question, guys. Thank you so much for presenting, and thank you so much for attending the webinar. Surely within the next 2 weeks, we'll have the recording of the webinar available and the presentation available on our website too. And we'll send out a follow-up email to you guys so that you can access all of that. Again, thank you very much for attending, and that's it. All right.
Thank you
Bye,
everyone for
everyone.
joining.
Thank you, everyone.
Bye.